All right, so this is the worksheet that I uploaded if you want to follow along or to download yourself on your own computer or tablet or whatever. So I picked this worksheet because it kind of goes through in general these groups, and I wanted to make sure that we go through step by step. So alkanes are the simplest hydrocarbon. The general formula, do I have a highlighter? Oh, hold on. Sequence here. Oh, nice, is coming back in. All right. So the general formula for an alkane is CnH2n plus 2, where N is the number of carbon atoms. So for example, if you have one carbon, so general formula CnH2n plus 2. This is something that's important to remember because it will allow you to automatically identify based on a chemical formula if something is an alkane, alkene, or alkyne. So this is an important thing to remember. So CnH2n plus 2. If you look at the simplest alkane, which has only one carbon, and you substitute 1 for N, you will get the formula CH4. If you have a 2-carbon alkane, you get C2H6. So if you look at a formula like C2H6 and you look at the relationship between the 2 and the 6, you see that 6 is 2 times 2 plus 2. So that's the formula 2N plus 2. That makes it an alkane. Again, as I said before, the alkanes are considered to be saturated compounds because the molecules contain only single bonds. Now, the method for naming hydrocarbons, like I said, is going to be the same procedure every time. And the first thing that I want to explain is that the parent carbon name, because one of the things that we'll talk about a little bit later is that you can have branched chains. If you remember from yesterday, I said that organic compounds can be straight chains, branched chains, and rings. So for the straight chains, obviously that's fairly easy. You count the number of carbons. And then here is, oh, where's the next page? All right, well, I've only got 1 to 7 here, but I've got the last 3 on the next page. I'll just write it here. H, we've got oct, I, non, and J, dec. All right, so that's the complete list. There's a prefix that you use to represent the number of carbons in the molecule. So up until I think letter D, these 4 might be, well, probably are new, but from E to J, they are exactly the same prefixes that we use in grade 10 when we named molecular compounds like pentoxide, hexoxide, heptoxide, things like that. It's also the same prefixes that you use in geometry when you're describing like a hexagon, a heptagon, octagon, nonagon, decagon. The first 4, however, are unique to organic chemistry. So for 1 carbon, we use the prefix meth. 2 is eth, 3 is prop, and 4 is bute. I know it looks like but it's pronounced bute. Okay, so these prefixes are used to represent the number of carbons in the formula, basically what represents N. So for an alkane, which has only 2 carbons in it, the name is going to be ethane. So remember when I said yesterday that like the names are going to be instructions on how to draw these compounds. So we already see 2 examples of this. The first example, okay, why didn't that work? Oh, all right. Thought I had a laser, but I guess not. All right, the first example is F, which represents 2, and the second is ane, which means all single bonds. because we're in the alkanes. So again, as I said, the names of these compounds are going to be like a recipe or an instruction on how to draw it. So eth represents 2 carbons. Ane means that it's all single bonds. And so the formula, you can just go by the 2. So we've got C2 because of the general formula CnH2n plus 2. The molecular formula is C2H6, right? If n equals 2, then 2n plus 2 is 6. Then for an alkane that has 3 carbons, because prop is the prefix for 3, that's going to be propane. And now you're going to have n equals 3. So your formula is C3H8. For an alkane with 4 carbons, that's called butane. Formula C4H10. There she is. Okay, for an alkane with 5 carbons, that name is pentane. Again, the pent telling you that there are 5 carbons and the ane telling you that they're all single bonds. Formula, Formula is CnH2n plus 2. If n equals 5, that means it's C5H12, 2n plus 2, yeah, H12. For hexane, I'm not going to go through all of them, so that'll be C6H14, but you get the idea. So basically, when you go from one alkane to the next, you are increasing by 1 unit of CH2. Oops. This is what we call a homologous series. If each member of the series is different by 1, oh my God, I don't know how to stop that. If each member of the series is different by the same unit, being CH2, we call that a homologous series. Okay, so these are the prefixes that you have to remember. They're going to be the same prefixes that you're going to use to indicate the number of carbons, whether it's the parent chain or whether it's a branch, which we'll talk about later. Okay, so now here we have the structural formulas. Again, these are the expanded structural formulas. You can do a condensed structural formula this way. Sorry, my brother just bought a new house, so they just moved in. They're all excited. Okay. So we've got the molecular formula, which is also the chemical formula. I would call this the extended or expanded. Oh, it's extended maybe. And the condensed. And then again, I don't really know how to call the super condensed one, but the one I showed you yesterday, which is just using the lines for butane, because there are 4 carbons. We start again counting as soon as our pen hits the paper. So that's 1, 2, 1, 2, wait, 1, 2, 3, 4. Okay, all of these are different types of formulas. So instead of condensed structural formula, I'm just going to do the super condensed because, like I said, I want to do this when possible. But also keep in mind that when you've got the ones in the middle, because we're talking about alkanes, they're all going to be CH2s, and then you're going to have CH3s at the end. And then you just do however many carbons are there. So for pent, it's 5. So I would just do 1, 2, 3, 4, 5. If you're going to do this version, then you just start with a CH3 at one end, and then you need a CH3 at the other end. So that's 2, and you need a total of 5. So you do CH2, that's 2, 3, 4, and your last one's going to be a CH3. Okay, either of those are acceptable. Let's go to decane. So that means that there's 10 carbon atoms, and the general formula is CnH2n plus 2. 2 times 10 plus 2 is 22. And if I do the condensed formula, I start with a CH3 and I add CH2, that's 2 carbons, 3, 4, 5, 6, 7, 8, 9, and my last one is a CH3. Or I can start with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's also a decane. Of course, you don't want them to be curved. You want them to be pointy. So that's how you name them. So the last part for alkanes is with alkyl groups. Now, alkyl means branch. So carbon chains are not rigid structures. They bend and flex freely, which I mentioned yesterday because they are single bonds. So when we say that an alkane has a straight chain, it doesn't always necessarily mean straight. It means that it's a continuous chain rather than a chain that has a branch on it. So there's 2 structural formulas that you see there. They both contain 6 carbon atoms, so they are both isomers. But if you see the one on the left-hand side, and this is a habit that I would recommend that you get into when you start to do these yourself, is to first, I can do a dash line, maybe I'll do that. And let's do 50%. Okay, so I would start with trying to identify a parent chain. So again, if they're single bonds, even if the position is different, it doesn't mean that it's a branch. So if you follow this, this is one continuous chain, which you can see there. Maybe I should try to make that a bit thicker. So what I usually do is I highlight the longest chain I can find. But in this one, you see if I go across here, this part is not part of the continuous chain. That is a branch. And if I try to go this way, again, this is a branch. You can't include all 6 carbons in one continuous chain. That makes either this one or this one an alkyl group. And there is a method for choosing which one it's going to be, which I'll talk about later. So it's important to be able to distinguish between a continuous chain and a branched chain. So most alkanes are going to exist as branched molecules like this one. So the first thing that you have to do when you're going to name a structural formula is you have to find the longest continuous chain that's not necessarily straight, but the longest continuous chain that you can find. So you would find something like this, and you could count from either left or right, doesn't matter, and go down this way. So if you did that, you would count as I go through the carbons, 1, 2, 3, 4, 5, 6. Okay. I could go straight across, 1, 2, 3, 4, 5, 6. That's another option. Or I can do 1, 2, 3, 4, 5, 6, 7. So obviously what is highlighted there is the longest continuous chain. Now what that means is that this, oh, that's pretty thick, and this are alkyl groups. Okay. Alkyl groups are attached to the longest continuous chain. When written alone, they're usually shown with a free bonding site represented by a dash. So that basically when they're written by themselves, you just write them as a dash and then whatever the chain is. So let me change the thickness of that. So for this one, you would represent it as dash CH3. This one would be dash CH2 CH3. That's if they're by themselves. Now, the way that you name these is using exactly the same set of prefixes that we do for the parent chain. only instead of the ending "ane," which represents the parent group, we're going to use the ending "ill." So let me just back up a second. I don't want to get ahead of myself, and I feel like I am. Solid, okay, let's make that 7. Okay, so when you're going to name this compound, first thing that you do, let me just erase all that. First thing you want to do is identify the longest parent chain, which we've done here. So you identify this as your longest parent chain. You count how many atoms are in the parent chain. So we count 1, 2, 3, 4, 5. Don't forget about that one. 6 and 7. So the prefix for 7 is hept. Okay. And it's an alkane because we see all single bonds there. So the parent name, which I want you to write on the right-hand side because it's the last name in the whole name, if that makes sense, because you're going to have multiple names. Remember, I told you it's instructions. Oops. My bad. Hept. So the parent name is heptane. That is the last term in the name of this compound. Then what you're going to do is you're going to identify the alkyl groups. Okay. You're going to put the names of the alkyl groups in front of the parent name heptane, but you're going to put them in alphabetical order. So again, we've got one alkyl group or one branch that has one carbon. One carbon, the prefix is meth. And because it's a branch, the ending is ill. So CH3 as a branch is called methyl. And the other one here that contains 2 carbon atoms is ethyl. So again, all of these names are instructions that describe what it's made of. Eth means 2, ill means branch. So you have a branch that has 2 carbons in it. You have to put these names in alphabetical order in front of the parent name. So I've got ethyl comes first, and then methyl comes second. The last thing that you do is you have to identify what are called position numbers, which means of the 7 carbons in heptane, you have to tell me on which of those 7 carbons is methyl and which one contains ethyl. Now, this is where it might get complicated because you have to number the parent chain in either direction that gives the alkyl groups the lowest possible number. So the way that I've numbered the carbons in heptane right now, that means that ethyl is on number 4 because it's attached to this one. So that would be 4 dash ethyl, and punctuation matters now. So 4 dash ethyl dash, and then the methyl group is on number 5. 5 dash. So according to the way that I have numbered this parent chain right now, this compound would be called 4-ethyl-5-methylheptane. However, what happens if I number it from right to left? Will that give me lower numbers? So if I start here, 1, 2, 3, 4, 5, 6, 7. If I number it this way, that means that the methyl group is on number 3. So I put a 3 here. And the ethyl group is on number 4. So ethyl doesn't change. Whether you go from left to right or right to left, ethyl doesn't change. But if you go from right to left, methyl gets a lower number. So 4,3 is lower than 4,5. If you end up with a compound that has, say, 4 or 5 branches on it, the easiest way to determine which direction you number the parent chain from is just to add up the total position numbers. So the numbers we had before, 4-ethyl, 5-methyl heptane. So what I would do if there, I mean, it's easy to see here that 3 is less than 5, but I'm just saying, like, if you've got 4 or 5 branches and there's a whole bunch of numbers there, just add the totals. 9 is more than 7. So you go with this one. You have to give the lowest numbers to the alkyl groups. That's the same method you're going to follow for every single compound. So again, you find the longest parent chain first. You name that according to the prefixes. Because we're in alkanes, they're always going to end with ANE, indicating they're all single bonds. The next thing that you're going to do is identify your alkyl groups. Put the names of the alkyl groups in front of the parent name. And then lastly, you're going to identify position numbers. And you can number the parent chain in either direction to give you the lowest number. So here's an example. We've got, so I'm going to change that to yellow again. All right, let's look at this example. Pretty easy. So just to be clear, we can either just go straight across, in which case we have 1, 2, 3, 4, 5, 6, 7, 8 carbons, or we can go 1, 2, 3, 4, 5, 6, 7. Nope, 8 is still more than 7. Or we can go 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there's 2 possibilities to have an 8 carbon chain. Either way, 8 for sure is the parent hydrocarbon. So I'm going to call it octane. Now the question is, do I go from the top down and to the right, or do I go straight across? Now, if I go straight across, then that means that this is my alkyl group. That is a propyl, and it would be on number 1, 2, 3, 4. So it will be 4 propyloctane. Because going from right to left, it'd be 1, 2, 3, 4. It would be 5. And 4 is less than 5. However, if I go from top down and to the right, that means this is my alkyl group, which is also a propyl. And if I count starting from the top, 1, 2, 3, 4, it's still 4 propyloctane. So in this example, it doesn't matter whether you follow the pink parent or the yellow parent, you're going to get the same name. So either way, this is called 4-propyloctane. Okay, so again, just to go through a couple more examples. Here you've got a large alkane. You identify the longest continuous chain that contains 11. Oh, I forgot the prefix for 11. Shoot, I'll have to look that up. Okay. I'll look that up later. I can't remember. I know 12 is dodeca. Anyway, let's just pretend it's 10 because I can't remember. But anyway, it's going to be called, I'll just say dodeca because I know 12 is dodeca. So that would be dodecane, even though it's not, because I know it's 11, but just bear with me. Okay, so then once we identify that, we identify our alkyl groups. So anything that's not highlighted, this is why I recommend highlighting or circling your parent chain so that it's very clear what the alkyl groups are. In this case, we have 2 alkyl groups that are both the same. They are both ethyl. The problem is the name of the compound has to be specific instructions, which include everything. So if I have 2 ethyl groups, I have to indicate that in the name. So I have to put in a prefix before ethyl to indicate that there are 2 of them. So it becomes diethyl. Okay, again, it's like step-by-step detailed instructions. The last thing I need to do is assign position numbers. So here's where it might get tricky. I'm just going to start from the top and see which two numbers we end up with. So I've got 1, 2, 3, 4, 5, 6, 7. So I've got 4, 7. But if I go from the other way, it's 1, 2, 3, 4, 5. That already tells me that the other number is going to be bigger. So I go with 4, 7. So 4, 7 dash. This is the punctuation that you use when you have more than one position number in front of an alkyl group. So there's always a dash before and after the number between names. But if you've got like a diethyl or a dipropyl or a trimethyl, you put commas between the numbers. Okay. Now, sometimes I see a space between the alkyl group and the parent name. Sometimes I don't. It just depends on the textbook. But either way, there's no dash. There's no dash after the last alkyl group. Okay, and another example. The longest chain here contains 8 carbons. The prefix for 8 is oct. We're still in alkanes. So we identify our alkyl groups. It's going to be too big. So we've got methyl here and ethyl there. We put them in alphabetical order in front of the parent name. So I'll just do methyl, leave some space for position numbers. And finally, position numbers. So if I start counting from this end, because this is the shortest end here, I'm going to end up with 3 and 5. The 3 belongs to methyl. Make sure you don't mistake that. So I've got 1, 2, 3. That's where the methyl group is. And 5 for ethyl. So 5-ethyl 3-methyl octane.